This question appeared on a video about how to get data from a closed Excel file using a combination of VBA with ActiveX data objects. Alex is struggling with the limitation of the 255 columns you're allowed to select, which admittedly is a bit of a problem if your data source contains 1500 columns. So I've set up a couple of basic files just to help demonstrate one technique for getting around this. I'll drop a link in the video description so you can download both these files yourself. The data source is nothing special. I've just made sure it's got way more than 255 columns in it, inventively called column 1 through to whatever column number I've ended up with, 2500 I think. There we go, all the way to column CRD. The data itself is completely uninteresting. It's just a number representing the number of the column. I've included just 5 rows in that table. I'll just close down the data source file there and show you that I've got the basic boilerplate code for selecting this data. So I've got a blank Excel workbook basically with some VBA code in it. This is fairly standard stuff. We've done this in a multitude of other videos that you can have a look at if you're interested in the absolute detail of what's going on here. But just roughly speaking, we've got a set of code that generates a new worksheet to output our data into. The standard code for creating a connection to our closed Excel file, so using my data source in the same folder, same folder as this workbook is. The code to create an empty record set, the basic SQL statement to select everything from sheet 1 in that workbook, and then a little bit of extra code to write out the column headers, and then just paste everything from the record set into the worksheet. So even though I'm saying select every column from sheet 1, and as we've just seen there's 2,500 columns in there, if we execute this code, what we end up with in our workbook is just 255 columns. That's the limit of ADODB there. So let's have a look at what sorts of things we can do to get around this limitation. The key to solving this is knowing that we don't always have to select from the entire worksheet in one go. We can limit the range of cells considered in the from clause by adding references to columns in there, for example. This is something we've covered in a bit more detail in our series on writing SQL for Excel files, so if you're interested in more detail, then I'd refer back to this playlist. Just for the sake of demonstration, let's say that I wanted to import my data just from columns, say X to AG. So if I just add that set of column references there at the end of the sheet reference, when I run this subroutine now, the new worksheet that I get contains just that set of columns. So basically what we want to do is take our full range of 2,500 columns, or more or less, and then divide those into groups of 255 so that we can import each set of data piece by piece, paste the data side by side, and eventually reconstruct the entire data set. So the first step, I think, is to work out how many different sets of 255 columns I'll need to import. This will basically determine the number of times we have to loop to reconstruct our select statement and pick the next block of 255 columns. I'd like this to work in a fairly flexible way as well. I know that the workbook I'm importing from now has 2,500 columns, but I want this to work to potentially import every single column from a worksheet, all 16,384 of them. So let's use a few variables to calculate these various values. I'm going to start by declaring a constant called cols per group, and this is going to be an integer that will hold the number of columns in each group. We might as well set that to be the maximum of 255 to begin with. Then I want to know what's the maximum number of columns I might ever be importing, and I'm going to determine this by reading how many columns there are on a worksheet. So let's say dim max cols as integer. And then after we've created and selected our new worksheet, I'm going to say max cols equals ws.columns.count. So that will deal with the possibility that in the future, Excel increases its worksheet size yet again and increases the number of columns available. I'm going to assume for the moment that the data source that I'm importing from and the workbook containing my output worksheet are of the same type and version, so they have the same number of maximum columns on them. Then to work out the number of column groups, we're going to divide the maximum columns by the number of columns per group. And let's store that in another variable. I'm going to say dim, let's say col groups. In fact, I'm going to call it col groups dbl, and I'm going to use the double data type just to begin with. I'm going to say col groups dbl equals, and then max calls divided by calls per group. Try that again, calls per group. There we go. And then I just want to indicate what that value is. So I'm going to say debug.print call groups double. And then just to make sure that I don't accidentally run all of the other useful code below, I'm going to say exit sub temporarily. We'll delete that in a few minutes. Okay, so at this point, if I were to execute this subroutine, I end up with 64¼ groups of 255 columns to import. That means that effectively I want to loop 65 times to make sure that I get the remaining quarter of 255 columns, the partial group at the end. I have to be slightly careful though about just increasing that value by 1 and just taking the integer portion, because if I was importing my data in such a way that I ended up with a whole number group, let's say for example I was going to import my columns in groups of 64 columns at a time for some reason. If I run that subroutine again, if I run that subroutine again, I end up with exactly 256 groups of columns. And I wouldn't want to increase the number of columns, column groups by 1 to deal with a non-existent empty group. So I only want to increase this value if this is a fractional, a non-integer number. So let's declare another variable that's going to hold the integer version of column groups. So I'm going to say dim col groups as integer. And then once I've calculated col groups double, I want to check if col groups double is the same as the integer version of col groups double. Just to demonstrate that quickly, in the debug.print statement, I'm going to use the int function to say int col groups dbl. So this will return the integer portion of that number. So at the moment, if I just clear the contents of the immediate window, if I'm importing in groups of 64, those values will be identical. If I go back to the maximum of 255, then when I run the subroutine again, these two values are different. So I can use that basic technique to test if these values are different. I want to take the integer portion of that number and then add 1 to it. So let's say col groups equals, and then I'm going to use the if function. I'm going to check if col groups dbl is equal to the integer version of col groups dbl. And if that's the case, then column groups will simply be equal to the integer version of col groups dbl. The integer conversion there isn't actually necessary. That will happen automatically or implicitly because we're storing that number in an integer variable. But it's always nice to be explicit about stuff like that. If those two numbers were different, I want to take the integer version of col groups double and then simply add 1 to the result. So let's say int col groups double plus 1 and then close the parentheses. So if we then add to the end of our debug.print statement, col groups, hopefully this is all making sense. It will become clear why we're doing all this a little bit later. If I now run that subroutine one more time, there we go. So if I'm importing a partial group at the end, I need to loop one more time than the number of whole groups. If I found that I had an integer number of groups to import, then the result is the same. 256, 256, 256. There we go. Right, just a little bit of tidying up at this point. I'm going to reset the number of calls per group to 255. Then I'm going to remove my exit sub and my debug.print statements. We shan't need those. And then I'm going to go back to the Excel workbook and just tidy up a whole bunch of these extra worksheets that I just don't need. So let's delete all of those except for sheet 1. Okay, so now that we know how many groups of columns we need to import, let's set up the loop that will run that number of times. And in each iteration of that loop, I want to calculate the number of the first column we're going to import and the number of the last column that we're going to import. So let's declare a few more variables to help with that. Let's say something like dim n as integer for our basic loop counter. And then let's also say dim first col num in group as integer. And then let's just quickly copy and paste that to cheat and call that one last col num in group. Okay, now we can set up our basic for next loop. We need to identify the range of code that we're going to repeat. So once I've created my record set and set its active connection, I'm going to carry on reusing that record set to populate it with each subsequent set of columns. So the code that I want to repeat is actually from this section here. So rs.source all the way down to closing the record set again once I've finished with it. So highlighting all those lines of code, I'm going to hit the tab key to indent them one space. And then I'm going to wrap my loop just around that section. So let's say for n equals 1 to col groups. And then once I've closed down my record set, I'll say next n. Now, just to make sure that I don't accidentally run this one and select loads of data that I don't really need to at this point, I'm just going to comment out all the instructions in there just temporarily. Because what I want to focus on now is just how to calculate the first and the last column number for each group. So inside here, let's actually start with the last column in the column number in the group first, because it's slightly easier to calculate. If I say last col num in group, I'm simply going to make this one equal to the value of n multiplied by the number of cols per group. So if I'm on group number 1, if n is 1, then 1 times 255 means the last column will be 255. The second time the loop goes round, 2 times the cols per group gives me the last column I'll import of 510, and so on. To get the same for the first col num in the group, if I say first col num in group equals, then I want to take that same result. I want to take n multiplied by cols per group. And then I want to subtract from that the value of cols per group and then add 1 to the result. So basically that's going to work out the same number, 255 for the first group, subtract from it 255 and then add 1 to the result to mean that I start from column number 1. The second time it goes around, it'll do 2 times cols per group, which will be 510, minus 255, giving me 255, adding 1 to the result. So I'll start from column number 256. Okay, so hopefully that's reasonably clear. If I then just do a quick debug.print statement, and let's say n, let's go for first column number in group and last column number in group. If we were just to quickly run that one at this point, we'll see that we get our column groups and the numbers of the columns we're going to import for each one. Now, there is a small problem with the last group that I've populated here. I happen to know that the maximum number of columns in a worksheet is 16,384. And at the moment, we're clearly exceeding that limit. So for that final partial group, I want to make that the minimum value between n multiplied by cols per group or the maximum number of columns in the worksheet. So I'm just going to make a modification to that last column in group. I'm going to use the worksheet function called min, and I'm going to take the minimum value between either n multiplied by cols per group or the value of max cols that we calculated earlier on. So if I just clear the contents of the immediate window and then run that subroutine again, we'll see that the final column we could ever possibly import is the same as the maximum column number of the worksheet. Okay, so the next step is to convert these column numbers into the appropriate column letters like X to AG. And the way we're going to do that is by relying on this new worksheet that we've created and referencing cells in that worksheet and returning the address property from those cells. So let's declare another couple of variables to help with that. I'm going to declare something like col refs as string, and let's also have dim SQL string as string. We might as well construct our select statement and hold that in a variable as well. So before we debug.print anything, let's say col refs equals, and I'm going to reference a range of cells using our new worksheet WS, and I'm going to refer to cells 1, first col num in group. So that's row number 1 and whichever column number is held in that variable. And then the second cell I'm going to reference is basically going to be the same, but just using the last col num in the group. Okay, and then if I just close the parentheses at that point and refer to the address property of those cells, let's just add that col refs variable to our debug.print statement, if I clear out the contents of the immediate window and then run the subroutine at that point, so we can hopefully see there, we're getting the column references. Actually, we're getting more than that. We're getting entire cell references, which isn't quite what I want at this point. So rather than getting references to those specific cells, I'm going to refer to the entire column property of that range of cells. So this time, if I clear the contents of the immediate window and then run that, now we've limited it to just the column letters. Finally, I need to get rid of these $signs, these absolute column references. So to do that, at the end of the address property, we can indicate that we don't want absolute row or absolute column references by saying false and false. The row absolute is a little irrelevant, a bit redundant now that we've removed the row numbers, but let's stick it in anyway. Okay, so if I clear the contents of the immediate window again and run that again, that looks like some sensible column letters to me. All we need to do now is feed these column letters into our main select statement. So again, I'm just going to add a new line that says SQL string equals. Then let's just copy paste our existing select statement to begin with. And then we know that we need to replace x to ag with our explicit column references held in our colrefs variable. So let's say double quotes and then concatenate colrefs, and then concatenate the closing square bracket. I'm just going to wipe out everything from the debug.print statement apart from the SQL string. And then one final time to test, let's run that code again. And there we go. That looks like a fairly sensible set of select statements that we can now execute one after the other to retrieve the relevant sets of columns. Okay, so I think we're just about ready to give this a test to see if we import more than just 255 columns. Let's just tidy up the workbook first of all. I'm going to get rid of all these extra worksheets. Then there are a couple of bits of code that I'll need to tweak. Let's first of all uncomment all the code in our loop from rs.source through to rs.close. And I want to make sure that my source is set not from this specific string, but from the string stored in our SQL string variable. I want to make sure that when I write out my column headers, they don't start getting written out always from column number 1 each time. I'm going to reference my first column in group. And likewise, when we write the details from the record set into the worksheet, don't write them into column number 1 every single time. Use whatever the first column number in the group is. Now, this won't work perfectly first time. There is a problem, a couple of small problems, in fact, with this code at the moment. But let me just quickly clear the contents of the immediate window and prove that the main part does indeed work. If we run that subroutine, we're going to import more than just one set of data. You'll see that it's failed at some point, however. I hit the debug button, it's failed to open up my record set. And you can see that it's trying to open up a record set selecting from column CTC. And the 255 columns in that group from there. Let's just reset the code at that point. It's not too big a deal that it has fallen over yet, because we can see if we switch back to the workbook, we've got our full set of 2,500 columns extracted from our source data into this workbook. So now let's deal with the problem of the code crashing right at the end after it's finished importing all the data. It crashed when it tried to select from columns CTC onwards. And you can clearly see here that columns CTC fall way beyond the end of the data in the actual workbook. So it goes from a completely empty column to another completely empty column. And the select statement simply won't select from completely empty cells. So to solve this, I'm going to check at the end of each of my loops, just before I close down the record set, I'm going to check if this was a full record set, if the number of fields I've selected is less than the columns per group value that we set right at the start. If that's true, I know that this must be the last group I'm importing. So let's add a quick if statement just below here. I'm going to say if rs.fields.count is less than cols per group, then I know that I've imported a partial group of columns, which means that this must be the last group of columns to import. So I'm going to say rs.close, and then I'm going to say exit for to stop looping, and then say end if. The additional rs.close is just to make sure, of course, that if we're not exiting the for loop at this point, we still close the record set before reopening it again after resetting the source. So if I just clear the contents of the immediate window and then I run that subroutine again, we get the same end results, but you'll see that it's stopped before it tried to select from column CTC onwards. So we get our full set of 2,500 columns and no runtime error right at the end. So the condition that we've just added there works nicely if we end up with a partial group of columns to import in the last set. But if we were importing complete sets of columns, this isn't going to work. Just to quickly demonstrate that, let's change our constant calls per group from 255 to 250. And because we're importing exactly 2,500 columns, this is going to end up with a full group of columns right at the end. So we're going to end up with the same sort of error, but for a different reason. So I also want to make sure, if I just end the subroutine at that point, I also want to make sure that if when we attempt to open up a record set that causes a runtime error, I'm going to jump out of my loop and head straight down to the end of my code where it says cn.close. So I'm basically going to provide a way out for my code if something goes wrong. Basic error handling techniques, and again we have much more detailed videos on error handling in VBA. I'm going to add a line label called way out, followed by a colon, and then I've added that right at the bottom of my procedure just before I close down my connection. Then the line that potentially fails is the one called rs.open, as we just saw. So if I just run that one again, if I hit the debug button, it's rs.open which fails. So I want to wrap an error handler around that single statement. So above rs.open, I'm going to say on error, and then I'm going to say go to way out. So I just use my line label to get my code to jump down to that point. It's good practice to close your error handler or disable your error handler after it's handled the line that could potentially go wrong. And the way we do that is by saying on error, go to 0. So that just basically resets the error handling from that point to behave normally. So having done all that, if I were to run the subroutine again, we'll get our full set of columns once again. And if I now go back to look at my my output worksheet, I'll have ended up with all 2,500 columns, but with no runtime errors generated right at the end. Okay, so if we want to select every single column from a workbook that contains more than 255 columns, we've basically got the code that will do that reliably. But there's one little twist in the tail, because Alex added a little follow-up comment to his original comment saying that what his actual need is to select one specific column from his 1500, but he's just not sure where exactly that is going to be. So if we want to be able to select just that one single column, there's a few little tweaks we'll need to make to our code to make that work. So just to wrap up the video, let's see what we can do about that. If we head back to the code, should we make a separate copy of this procedure? I'm just going to modify the existing one actually. Let's create another constant at the top. I'm going to say const col name as string, and let's say arbitrarily I wanted to select column number 1638. So all the column names in my data are called column, simply followed by a number. So imagine that was Alex's explicit specific column name that he wanted to select. What I'm then going to do is head back down inside my loop, and I'm going to modify my original SQL string not to select every row and every column from that set of data. I'm just going to select the top one row, because I'm not necessarily going to be selecting data from that first select statement. This is just to generate the column headers that I want to test for. So I've got the record set source set and then the record set open, and then I've got a little section of code here that's looping through the list of fields or columns in my record set. And I'm going to use that to check if the name of each field is equal to the name that I've typed into my constant. So let's just change this part here that's writing my data out into the, these are writing column headings out into the worksheet. Let's remove all that and convert that into an if statement. I'm going to check if rsfields.name is equal to the col name variable that I've just set up. Bear in mind that this comparison will be case sensitive, so make sure your cases match, and there's various solutions you can use to make it case insensitive, which we've covered in many other videos. So at this point I'm just going to leave it with a basic comparison like so. So if that's true, I know that that record set contains the column that I want to select from. So what I'm going to do is close down the record set, and then I'm going to reset its select statement. So I'm going to basically copy and paste my select statement here. And I'm going to say rs.source equals, and then paste that select statement in. I don't want to select the top one row, and I don't want to select all the columns. I want to select the specific column name that we're interested in. So I'm going to concatenate in that col name variable. So I already know that I'm working with the correct set of column references. We've just established that with this if statement. So that will select the entire specific column. Then I'll need to open up my record set again. So let's say rs.open. And then I will want to, I guess, write out the column header into cell number 1 of my worksheet. So let's say ws.cells 1,1.value equals, and then write out the col name constant. And then I want to copy the data from my record set into the worksheet. So I'm just going to quickly move that line of code inside my if statement. And I don't want to start copying to the first column number in the group. So I don't want my column to be in column 1638 or whatever it was. I want it to be in column number 1, right at the beginning of the worksheet. Okay, once I've copied it out of the record set, I'm going to say rs.close. And then I basically want to exit from the entire thing at this point. I could say, if I said exit for, that would take me out of this for loop, but place me back in the next for loop. So I don't want to just exit from the for loop. I guess I could exit from the subroutine, but that would then circumvent cn.close. I guess I could say cn.close and then exit the sub. Alternatively, I could just say go to way out. But I'm not a big fan, since about the 1980s, I've not been a big fan of using go to statements for manipulating your code, the order of execution. So let's say cn.close, and then let's say exit sub. So just stop the entire process at that point, having closed everything down. Okay, so with all that in place, and assuming I haven't made too many horrendous mistakes, what we should end up with is just one single column in our output, this time column number 1638. So let's give that a whirl. If I run that subroutine, looks like it's found it in one of my groups of columns. Oh, I'm still going by 250. Never mind, doesn't really matter. And there we go, column 1638 selected specifically by itself into our output sheet. Phew. So I hope that fairly comprehensively answers the question that Alex had. If not, as always, feel free to carry on asking more questions. I'll see what I can do about answering them. Otherwise, thanks very much for watching. Hope you enjoyed it. See you next time.